So 10.6, we're looking at segment lengths in circles. We're basically going to look at two rules. It's kind of three rules, but it's mainly two rules that deal with what about segment lengths inside of a circle. So way back in 10.4 and 10.5, we saw a bunch of these rules for like angle measures inside of a circle, outside of a circle. That's what we're going to be talking about today, only instead of angle measures and arc measures, we're going to be talking about segment lengths of like chords and tangent lines and stuff like that. So our first rule is the easier of the two. It says that if two chords intersect inside of a circle, then the product of their lengths of segments of one chord is equal to the product of the lengths of segments of the other chord. So what this says, it's easier explained in the picture, is that when two chords intersect, you kind of like, if you look at this green segment AB, you kind of break it up into an AE chunk and an EB chunk. And the same thing for the red chord, a CE chunk and the ED chunk. And what that's saying is that EA times EB is always equal to CE times ED. So it's saying the products are equal. Not that the lengths are equal, but the products of those are equal. So here's an example. We're going to look at two examples. ST and PQ intersect inside the circle. So you can see QP is broken up as like 9 and X. ST is broken up as 3 and 6. So what this is saying is that 9x is equal to 3 times 6. So 9x is equal to 18, so x would have to be equal to 2. So you're taking each of the chunks that it gets split into, multiplying them together, and setting them equal to each other. We'll try another one, a little more algebra heavy, but not so bad. Solve this equation for x round to the nearest tenth. Well, we have to just set this up the same way as we did the last one. So I'm going to do x times x plus 10. I'm going to remember to use parentheses like a good kid. Equals x plus 4 times x plus 2. Now we solve that. Don't be afraid of the algebra. We can distribute here. You get x squared plus 10x. And then on the left you have to FOIL. So to review foiling, we've done some of it this year. You do first times first. That's x squared. Then you do outside. FO. Outside is 2 times x. Then you go inside. 4 times x. So plus 4x. And then you do last. 4 times 2 is 8. In theory, all of you have done that in Algebra 1. We've done it a few times this year, but that's foiling. It's basically distributing the x to both pieces and the 4 to both pieces, just in a specific order. We can clean up the right side to x squared plus 6x plus 8. And now this looks intimidating to solve, but when you subtract x squared from both sides, the x squareds just go away. So you have 10x is equal to 6x plus 8. Subtract 6x, you get 4x equals 8. So x once again is equal to 2. If you want to check your work, 2 times 12, is that equal to 6 times 4? Yes, both answers equal 24. So that's rule number 1. Here's rule number 2/3. If you have a secant segment, so a line that goes outside of a circle, that also gets broken up into 2 chunks. So this red secant segment is broken up into chunk BA and EA, and the blue segment is broken up into chunks CD and EC. Now what's tricky about this rule is if we look at it, we're told the secant segment times just the external part, just the outside part, is equal to the entire secant segment times just the outside part of the blue one. So symbolically, EB, the entire length, times EA, is equal to the entire length times EC. Now what can be dangerous about this is so often we're tempted to just do CD times EC is equal to BA times AE, and that's just not what the rule is. It's the entire length times the outside. Entire length times the outside. We'll try an example of that. We'll try this one right here. Then we'll look at our third rule. That's pretty similar. So our rule is the entire length times the outside is equal to the entire length times the outside. So here you got to know the entire length of this thing is 20. So the entire length is 20 times the outside, which is 9, is equal to the entire length here. Be careful, it's not 10x, it's 10 plus x. Times just the outside, 10. So that means you have 180 is equal to distribute in 100 plus 10x. Subtracting 100, 80 is equal to 10x, so x is equal to 8. For this rule, it's the entire length times the outside. If you tried to do 9 times 11 equals 10 times x, you would not get the same answer. Entire length times the outside. Okay, let's look at our third rule, which is very similar to our second rule. If you have one secant segment and one tangent segment, you still do the same thing with the secant segment. You can say entire length times the outside piece, but then you just set that equal to the tangent segment squared. So EC times EC. So our last example here, we take the entire secant segment, which for us is 7 plus x, times the outside piece, just 7, equals the tangent part times the tangent part, 10 times 10. Distribute in, 49 is equal to, or plus 7x, sorry, is equal to 100. Subtract 49, 7x is equal to 51. Divide by 7, you get 51 over 7. If you want to round that, you can. You're going to get 7 point something. But that's the game here. Entire length times the outside. And if it's a tangent, it's just outside times outside. So you'll notice this rule is a little more difficult than our first rule. Remember, the first rule is just chunk times chunk equals chunk times chunk. That's really official math language, clearly. But that's kind of the best way I can describe it. So go ahead and give the homework a shot. See how you do.